Hey, I'm Brian McKeiver. I'm the speaker that almost didn't make things work with his computer. I'm going to blame Microsoft or something, but we're here. My talk today is state-of-the-art search with Azure AI Search. How many people in the room use Azure AI Search? A couple of you. Awesome. So if I'm stuck, I'm calling on you all to help me answer. I would like to take a moment to thank the sponsors and organizers of this conference. This is my first time here from Grand Rapids, Michigan. Grand Rapids, Michigan. I say it quietly because I'm in Ohio. I know we don't like each other a ton, but I promise I'm a very friendly person. And I want to thank the organizers and sponsors because we wouldn't be here without them, right? So quick, hey, great PowerPoint animation. All right, it worked kind of. And I've lost like at least 11 minutes, so I'm going to go a little fast. But I have been a developer for about 20-something years. I'm recognized for those skills as a Microsoft Azure MVP, a Kentico MVP, and a Content.ai MVP because my company, BizStream, builds enterprise-class websites for people across North America, and we typically do that with content management systems. So anyone in the room use a content management system like a WordPress or Sitecore, Drupal? Okay, a couple of you. So I just say that to give you the context of the rest of the talk, because my talk is how to integrate Azure AI Search into a website, basically, or an application. And I've heard this statement at least 300 times in my career. Hey, isn't search easy? Can't you just make it work like Google or Bing or Amazon? And that expectation is what makes this difficult. Because people just think it works, because it works great on these sites that we're used to using today in 2024, right? But sometimes this happens. You search for a term on your application, and you're like, crap, there is some content in the world about Java, right? It's a programming language. It's coffee. There should definitely be like a billion results. But this happens in the real world, sometimes on Microsoft Bing or Google or wherever, sometimes in your own applications. Maybe you're building an e-commerce website, and you're trying to find your product, and you put in that keyword, and suddenly no results happen. And you're like, doggone it, it's going to be a long night. We got to figure this out. What I'm trying to say is search is hard. It's hard to deliver a good quality experience with search because it's complex. We've got lots of data typically on websites. We have changing data over time that we need to be able to respond to. What happens when somebody renames a product or rebrands a website or has a different news service that they didn't before? So you have to kind of keep it up to date. You've got to give it some tender love and care. You've got to make sure it works pretty well over time. You can't just build it once and forget about it. And then at scale, people expect it to run fast, right? If you don't get a search result within a second or two, what do you typically do? You leave. You move. You try some other, this thing doesn't work. I'm going to try something else, right? It happens all the time. Anybody else have a reason in the audience why maybe search is hard? Has anyone tried to build search themselves on an app? Stephanie, yeah? Is it easy? No, yeah. And I've actually done it myself in, like a long, long time ago, classic ASP days with SQL Server, and it kind of ended up like this. Yeah, so theme of the conference is Star Wars. I had to go there. If people think they can just make a quick SQL query to do searching, typically it doesn't end well, and it could destroy the server that you're on, right? So I'm here today to talk about the next generation of how to provide good search results, how to provide a good search experience. And one of the ways you can do that is through Azure AI Search. I think the title gave it away a little bit, but that's where we're going to talk about as a solution to all the problems that we've just mentioned. So a couple people in the room use it, but not everyone did. So to explain it at a very high level, Azure AI Search is a search resource in the cloud, and it allows you to offload your resources and leverage the power of Microsoft Azure to ingest data, query data, and deliver results. You have a PaaS resource that you spin up in your Azure subscription, and you're kind of off and running. And it works really, really well. Now, the talk I want to get to today, the meat of the talk, I don't want to spend on like the simple basic things. So yes, there's a search query box. When you plug in a query, you get search results. I'm hoping everyone can kind of envision that. But the resource or the service from Azure includes all these kind of built-in things. It has a way to boost results, to change the way the order of the search results appear. You can do facets. In fact, think of the checkbox on the left side of like Amazon or Best Buy or HomeDepot.com. All those, I want to get to this category and then this category, and all those numbers updating really fast. This tool does it really, really well. Better than you would do the SQL Server, I guarantee it. It can do auto-completion or type ahead. You can have synonym searching. All these things you just kind of get with the tool. I'm just saying it does that, and you trust me on those things. Because I want to talk about why it's different than you building it yourself. Before I do that, here's how it really works. Okay? It starts in the middle of this diagram. And that's where the brain is. In fact, it used to be called Azure Cognitive Search because it was all about the cognitive service that Azure has. That's now been renamed to Azure AI Search, but not every document is up to date yet. But the middle is the brain of the operations. And your job as the developer is to handle the left side of the diagram and then the far right side of the diagram. Because you need to get your data into an index. And that index is stored in the cloud in the middle of the diagram. And that data can be almost anything. It can be structured content, unstructured content. We'll get to that in a second. But you have to get the data up to Azure. So out of your SQL Server, out of your file systems, if you've got a large amount of PDFs or something, you have to get it into Azure. And there's multiple ways to do that. I'll show you like 3 different ways to do that today. And once you get it there, all the logic of matching terms and understanding what's there, that's what the tool does for you. And once you get it there, you can consume search results based off queries at a REST API, at an SDK, at an API. There's ways to get the data out and basically deliver your search experience. Hoping this makes sense because this is a really like the key aspect of how this service works. We index data so that we can process it and we can query against it, and then we deliver results. And on the ingesting side, or the intake of data, there's 2 major categories of data that it can search. The one that we're probably more used to is dealing with structured data. And that is like, think of like data in a SQL database table, a code object, a well-defined object that has properties. Or think of a web page like an article. An article has a title, a date published, the body copy, maybe some images, maybe some metadata. All those things are fields or structured content. And you can take that structured syntax or scenario or schema and make that the index so that way the search tool knows what this is. But what people don't always think of that you can also search is unstructured content. And the best way to think about that is kind of where the screen says, but it's maybe PDFs where there's no schema associated with them. It's a list of CSV files that have no definition. It's images, it's video, it's sounds. The power of Azure AI Search is that it can combine both of these types of data and put them into one set of search results, which is something that's pretty cool, and I'm going to show you how to do some of that. So the unstructured data is kind of hard to visualize. One of the things that Microsoft has done is provided a demo site that actually searches the JFK files. And in this example, I've typed in Oswald into the search bar, and you can see it actually found scanned images of handwriting of the word Oswald. It found, and it highlighted them over the top of the image, or it will highlight your text and tell you where it found that. It will then tell you what kind of entity it found it in. You can have the facets come alive like the left sidebar here shows. And it's something that is powerful if you're in this kind of business where you have lots of images or scans or PDFs that you need to be able to search and find quickly. So it's a good way to deliver like a knowledge search solution. And I think that's pretty cool. All right, but again, we're at a conference. It's themed about Star Wars. And this is my simple example to start showing off the real tech. I have a JSON file. It's an array of objects about Star Wars characters and what movies they appeared in, where they're from, via their home planet, and do they use the Force or not. Just trying to show off a couple different kind of data types. And honestly, I couldn't think of a better example to use at the conference. So what we want to do is take that JSON file with all the array of objects, and we want to be able to search that to find where's Yoda from or something. And the way it works is we need to take that JSON file, put it into a blob storage container in Azure, create an index, and then deliver results to a web page. So this is the first basic building block of how Azure AI Search works. It's like the simplest starting point. And instead of trying to get the internet to work, I've actually recorded a demo where I've provisioned a search resource. I'm clicking the Import Data button, and there's lots of choices of where to import data from. I'm clicking Azure Blob Storage. I'm giving it like a data source name, and I'm telling it I want to extract the content and even some metadata of the file. And I have to tell it that I'm looking for a JSON array with a parsing mode. Pick a connection string to my blob storage account and my container, which is, hopefully you already have something like that set up, so it's kind of easier, more just clicking which connection, which account, which container. I have one called Star Wars. And when I do that, the power of the search tool is it's going to inspect that file and automatically give me an index configuration. I'm skipping the middle step, but right here, I'm going to try to pause it really quick. So, the index is the most important part of delivering search results. And here you can see it found the JSON attribute names, put those in as the field name, and it gives me choices at the bottom of the screen. And it's asking, do you want to search this field or not? Should it be retrievable in search results? Should it be facetable or sortable? And it gives you control over how you want that data to be searched, and that sets up the rest of the stuff. So as I go through, I'm going to make sure a lot of these things are retrievable, searchable. I'm going to grab the field names of the file that we have our content in, and I'm going to grab a metadata field of like the file name it came from. And if you look really close, there's one key field there with the little key icon. It's going to give me like a primary key because we need to have some sort of unique identifier. This is a really simple kind of dumbed down example. Typically you would have a real like identifier of your content in there. But once you click through, configure your index, you then have to set up what's called an indexer. This is the thing that will actually parse the data from the storage account, put it into the index inside of the search resource, and deliver the populated index into your Azure search. And it does that really, really quick. By the time I click next, it was finished already. I'm then going to navigate to my indexes inside of Azure AI Search. I'm going to click the Star Wars index that we just made, and it gives you a nice little search preview tool where you can actually type in some search words like Star Wars or Yoda or just asterisk to give me all results. And now what that has done is made a simple HTTP request to my endpoint in Azure Search, which is search mcbeevdemo.windows.net, blah, blah, blah. And I've searched for Yoda, and I have a score that I actually only have one node for the Yoda example, but it's giving me how relevant is this scored result to the term that I searched. Did that make sense? Okay, cool. Sorry? Yeah, we'll talk about scoring in a little bit, okay? So what we did there is create a data source in the Azure AI Search world that has our Yoda JSON. We made an index, we populated it, and then we delivered the results to the search tool. That could be anything that can make an HTTP request, but I'm using the Search Explorer to show it. But what can happen on top of just indexing that data is we can put skills in the indexer processing of each record. And the reason it's called Azure AI Search is because there's a couple built-in AI-based skills that as you index content and you look at images or text, you can do special things using the rest of the AI cognitive services library that's available to you. And it has a couple built-in ones like image analysis. So if I put this image into that blob storage container and I wanted to index my images and not have to worry about tagging that image, you can actually run something that would automatically extract and call this image, it's a sport, it's a person, they're skating or skateboarding. So pretty powerful if you have thousands of images that you want to bring in and be able to search across. We'll also do entity recognition, so it will kind of know what each of these things is. So here's a set of stickers that have different Azure services logos. It knows that that logo is actually Azure Functions because it can call out to Bing as one of the built-in enrichment skill sets and bring back that result based off that image being searched. It can also do keyword extraction. So say you have thousands of words in a paragraph or novel or whatever, you can bring out and extract that in that JSON, we are looking at these keywords of web development and .NET and Azure out of that whole set of text. And what it can do is run it through this enrichment pipeline. So I'm going to do one other aspect of making it a little bit more real than just the Yoda JSON. And I'm going to run it through a pipeline that, in theory, could call out to like the Swappy API, where we could connect that Darth Vader, his home planet is from Tatooine, and maybe I want to call out to swappy.tech and say, what do you know about Tatooine? That API response is going to bring back like the diameter of the planet, the climate, the terrain, and inside of that enrichment pipeline, you could take that API response for the Darth Vader record and combine that information to deliver a more full API response in your search results that now combines what I have in my JSON file with live API calls. So you can start stringing together multiple systems and multiple data sources to provide that kind of rich federated search or combined search results. And that's done through a skill set. We do this often for different scenarios in the websites that we build, which is why I'm showing this one because a couple of other demos use it as a basis. But moving away from just simple JSON, that's static, and talking about delivering it to a website where content changes daily. So at my company, we do a lot of work with Kentico. It's a great content management system. It's all in .NET. It's supported in Azure. It does some pretty cool things. So I have my personal blog at McKeiver.com running on Kentico connected to Azure AI Search. And I can provide search results on my blog based off all the blog post content that I have. And here's a detail of a blog post about Kentico that I've written. And when I go back to the home, you can see other articles. But if I click search, before I click search, just quickly showing inside of Kentico, this is kind of a real-world example where you may have that blog post article as a defined structured object. Here is where I would go to look at all the articles I have. And each article has, like I was saying before, it has a summary, content field, name, author, published dates. Those are all structured fields inside of the CMS. And it doesn't really matter what CMS it is. It could be SharePoint or WordPress or whatever. But because I have that, typically I would want my search to be able to understand those fields to deliver facets or know how to set up a scoring profile to represent all that. So I'm just showing here I've got like the defined fields. And in my scenario for the real world of my website, I want article summary to be searched. So there is a kind of an automatic integration between Azure AI Search in Kentco that I define an index called xbk McKeiver, and I'm searching anywhere on my site. So that index I've got populated in the same search resource, because you could have multiple indexes in one search resource. I have a different configuration of this index. So here I have like content, title, summary, and if I search for the word Kentco in the Search Explorer, I now have basically like 20 different search requests off of the term Kentco, and that then is used by my UI of my blog, searching for Kentco. I see those same results in a visual way. All that works from as I create new content in my blog, make new blog posts, it keeps it up to date, it keeps the index refreshed, updated, and then I use that to power my website search. So that's a little bit more of a real-world example than just the Star Wars example. Pretty cool? Cool. All right, then this happened, okay? I'll be honest, I've given this talk multiple times over the last 3 or 4 years, and only in the last 2 years have I had to redo it every 3 months in the content, because AI changed the world, especially in the Azure AI search world. First, they introduced what was called semantic search. And semantic search is all about understanding the context of how we as humans write and read and understand language. Typically, if you did search before 2020-ish, you were doing keyword or lexical-based searching, where you would take a paragraph of words or a sentence of words, you'd break them apart by white space, and then you would just count how many times did the keyword appear in this article or document, and then that's the one you'd put at the top of the results. But that has a problem. If you just think of single word by itself, you don't know the context that's being used in. So if we were to search for the term test, there's a lot of different ways we can use test. And when we see these phrases, understand that a practice test and a certification test may be more in one context versus A/B testing and front-end test framework, right? Test is actually kind of a difficult word to search the right way. And what semantic search does is look at all of the different ways it knows in a large language model the way test can be used, the context, and it groups them together. And it says, you know what? Practice test, certification test, and passing a final exam test. That's an educational use case or context. And it starts putting them in those contexts so that we can provide more accurate search results. So if I'm searching for how do I pass this test, or my class has a test, we know we want to bring back educational-based results, not like marketing digital things of A/B testing or developer things like unit testing. And it does that by using semantic relevance, but based off losing a couple minutes, I'm going to skip through this one, and I'm just going to show you that I have enabled semantic search in my Azure AI Search Index by creating a semantic configuration. In that configuration, you just have to tell the AI connector that this is the field that has most likely the most contextual, correct use of these terms. So I'm saying use summary and content to do the semantic ranking, and also the title of what you should bring back is the article name. And when I do that, and I search again for the same Kentco keyword, I have a couple new responses that come up in the response that the Azure Search gives me. The first thing is not just search results, it's actually what's called search.answers. So if you've seen in Bing or Google or even a ChatGPT where if you ask it, what is this thing, it will answer you based off what it knows and then provide search results below, that's exactly what this is doing. So it's starting to use and understand the context to provide better answers, and then also re-rank the scoring based off context of how it's written and used. All of that could be said as it's more accurate. This is just a more accurate way of providing search results. And that's a big important thing because a lot of people want to have accurate search results. So there's the answers attribute and the re-rank. Okay. And like I said, AI has changed everything in this world. What Microsoft has done in the last year and a half is integrate Azure AI Search with OpenAI to provide what's called Retrieval Augmented Generation, or RAG. And the way RAG works is to augment what a ChatGPT model understands and knows already with up-to-date, relevant, or specific information that you know about your use case of your application. An Azure AI Search Index is the most popular way to implement this, because it's meant to do searching to find answers to questions and bring that back, include it with the chat response, and give you references of where this is used. So away from just the theory and into how this actually works. There's a new tool called the Azure OpenAI Studio, and that tool lets you create a playground to do basically a RAG-based scenario using Azure AI Search and using a deployment of a model. So here's the Azure OpenAI Studio. I'm going into the chat playground, and it assumes that I've done a deployment of an Azure AI resource. There's lots of other talks today about Azure OpenAI, so I recommend checking those out. But I'm asking it a question in chat only based off what ChatGPT 4 knows. So I've deployed a ChatGPT 4 model, and it's currently using what it knows about what is Kentico in the chat. And it actually answers it wrong, because the number 2 there, if we scroll really close, is not something that Kentico has anymore. It hasn't had it for like 3 years. So what I'm doing now is I'm grounding the LLM and the ChatGPT 4 deployment to my Azure AI Search Index that I just showed you all, connected to my blog about blog posts that I write about Kentico.NET and Azure. I'm picking an index from my Azure Search resource, and then I'm going to give it some mapping of fields to help it understand, again, like where's the content of the blog post coming from, where's the title, where's the article, where's the URL to it, the name. So you have to configure a couple fields. This is just like the playground, so it doesn't really matter which ones I pick. But what it does is combine the two services together. And this is becoming more and more important and useful and used in the real world. I'm picking that semantic configuration to enable semantic search, and I'm saving and closing, and I've just connected my Azure AI Search Index to Azure OpenAI. So now, when I ask it the same exact question, what is Kentico, it's going to combine what it knows as the model with what my blog posts tell it. And it is a much different answer, and actually it's a little bit more of an accurate, if you actually read this whole chat response, it's a little bit more up to date. And it actually cites references to my blog post. So 20 things Kentico developers should know, Kentico MVC page builder do's and don'ts. Those are actually contents from my blog post that it helped populate the answer with. And that is RAG. I think that's pretty cool. What are we doing on time? Okay. All right. So on top of semantic and RAG, then came vectorization. You may have heard about this in a lot of the AI stuff lately. Vectorization takes strings of words and phrases and puts them into vector arrays of numbers. And why would it do this? Anyone have a guess as to why we'd want to vectorize English words or other language words into numbers? Sorry? Contextualization. Yes, sort of. Basically, computers are better at matching numbers and knowing the difference between numbers than English writing. In fact, they're much, much better, and it's much, much faster. So what vectorization and vector-based search do is solve problems that even semantic and keyword search can't. So like misspellings, stemming or the start of a word, understanding how to realize that that's actually similar to the other thing that someone wrote. It's better at doing semantic matching, and it's a way to kind of look at the entire context of a query term with the entire set of words. So it's a bigger comparison, which again provides more accuracy. The way it works in Azure AI Search is, again, you have your search resources, you have your index, and you need some way to vectorize what you have in your data set and what the user is typing in the search bar. There's a couple different ways to do this. You could bring your own vector database service and have everything already vectorized, or you can use a brand new feature of Azure AI Search that just came out like a month and a half ago, and it's called integrated vectorization. And I'm very excited about this because there's no way me running my personal blog, I'm going to try to even worry about vectorizing all the content and have it stored somewhere else. The CMS doesn't do that. I'm not going to write custom code to do that. It's not maintainable. And that's why they really included it right in the product, because you create a vector profile, you tell it a little bit of where to go get the vectors from, which is called embedding. So to do that, you combine, again, Azure OpenAI with Azure AI Search. You deploy a embedding model, so it's a different kind of model compared to ChatGPT-4. So I've deployed a text embedding Ada 2 model, and I then configure that. Oops, sorry. Okay, come on. Play. I configure the Azure AI Search skill set to pass the data in my index to the embedded model, which will return the vectored information and put it into my index for me. So now you can see I've actually got summary embeddings coming back. Those are the numbers that represent the summary of my blog post as an array of vectors. And I'm going to kind of here turn on the vector-based search, and you'll see that you'll get different results. So the first time I queried for Azure, I got a blog post talking about how I'm an Azure MVP. But the second time I queried for Azure, it actually has blog posts that specifically talk about Azure services, mention them more, go more in depth, and that's a much better search result because the vectors allow us to have a different way of semantically knowing what is closer to this query term. The downside is it's a little bit slower to process your index, to go vectorize everything and bring it back, but you can kind of scale that up. You can meet your needs with other scalability tools in Azure. But before I get into that tangent, the way this works could be better, to be honest, but right now it's a set of JSON skill set definitions where I tell the search skill, go to text embedding model, use this endpoint, that's my Azure OpenAI endpoint, vectorize one field called summary, and then put that back into the index using the indexer, which has an output mapping of fields that you can configure and say, what index do I want to process this skill on, and where do I want to return the data? So I wish it was a little bit better. There's no like GUI for this. I mean, you can do it through code. Everything I've shown you today, by the way, you can do through the SDK and API that Azure AI Search has, but I wanted to kind of visually explain it, so I've stayed in the portal. But based off time, I'm going to actually move on. What happens to do the integrated vector querying is that you tell the HTTP post to your service to use a vector query object, and you say that I'm going to use the vectors that are in the summary embeddings field. So all that kind of lines up into this framework. You have your skill set. Your indexer is the thing that keeps it up to date and running. You can run that on a daily, hourly, or monthly basis, however you want to. That uses your index to put the vectors back into it. So super technical. I hope I didn't lose anybody there. But very cool, very powerful, a lot more accurate in delivering results. Search is still hard, but I've shown you a little bit of a solution to do that and how I've used it on my website at a high level, of course. I do think Azure AI Search is a good solution to the problem I introduced at the beginning of the talk. There are other tools out here in the marketplace that do AI-based searching. Algolia is probably the other well-known tool, but I do think Azure AI Search has some advantages over it. It's pretty nice. But instead of building search yourself and having it maybe use resources on your web server or even your Azure App Service or wherever you deploy your site or app to, you're using a different set of resources, which is why it's so fast. I was actually shocked how fast it was compared to just returning a database call to the .NET app. I mean, it's insanely fast. Like I said, fast. And it's reusable across multiple different apps. So say you had a mobile phone app or a different website, you could all use the same index, right? They're adding more and more AI abilities into it as fast as possible. They're using semantic search, they're using vectorization, which allows you to do federated search. But you don't have to take my word for it only. It's funny that this guy, the CEO of Microsoft, literally said this about a week ago. Azure AI Search, also which is used by ChatGPT, is one of the fastest growing services from Microsoft. They're obviously putting a ton of money into backing OpenAI, to delivering Azure OpenAI, and as I said, to do the RAG model with Azure AI Search, that's where the stuff is really growing, and Microsoft is even saying that it's widely used technology. So if you want to try it yourself, I got a couple links. I'll put some slides out there at where I think conference has a GitHub repo where the slides will be. So some links, where to get started, how to use RAG in your own data to power OpenAI in your own search. I didn't talk too much about semantic kernel. Semantic kernel is a somewhat SDK system for how to do everything I showed you via code and then actually plug in more into OpenAI as well as Azure AI Search. Kentco, like I said before, really cool .NET CMS. My blog's at McKeiver.com where I talk about these topics, and I have other posts about Azure AI Search. But I've tried to go fast to catch up a little bit on time. I've got maybe just a couple things left, but hope you enjoyed it, and we've got some time for questions.
We have one question on the Discord. Actually, a couple. The first one is, can the data source for a collection of documents Can the data source be a collection of documents like PDFs?
Yes, it's actually natively supports PDFs, and one difference with Azure AI Search is it won't just search the title of a PDF, it'll search into the PDF, the contents of the PDF. It can pull out, and you can use that to match what's in the content of the PDF. So a big collection of PDFs is one of the most common scenarios you'd use Azure AI Search for.
Okay, another question. Is there a way to let our business owners train the search? Example, our business user runs a search and sees the results. They say, no, this is the result we wanted to see at the top. And next time the system, make sure to put that result on top. Or would this be something we need to code ourselves? Load this data and access using a skill.
It's a great question. And I get this question all the time. Marketers love saying, I want this result to be first no matter what. Sadly, the short answer, there's not a direct way to pin one result to the top of results in Azure AI Search. The longer answer is, and I kind of skipped over this based off time, but you create scoring profiles. And a scoring profile can artificially affect the results order. And you can basically say, if I match the query term in the title of my blog post versus the body, that's a stronger indicator. And we do this all the time for our clients. If the title matches the word, give that a +1 or +0.5 into the scoring profile, and then that will bring that result closer to the top. And that is a more global solution for every search term, not just like one search term and one search result. So scoring profiles, you can have as many of them as you want on your index, and you can configure with rules and conditions. This should rank higher based off this set of criteria, and you can actually negatively rank results. We've had a client who uses this tool that they don't want their careers pages to come up in search. They want their services and industries pages to come up in search. So we actually negatively affect the scoring profile for any careers pages based off of a type field. And you can affect and change the results that way, and we've seen some pretty good overall performance with our analytics on search with that technique.
Any questions from the audience?
Okay. All right, well, if there's no other question from the audience, I know I'm in your way to get to lunch, so let's just call it. If you do have any other questions, you can hit my blog as a contact form. My email's right there. I'm on X/Twitter/whatever it's called these days. But again, I hope you enjoyed it and learned a little bit. Thank you. Oh, and one more round of applause for Stephanie. Thank you for letting me use your laptop. Thank you.